Okay, so today we start lesson 8.6, part 1. Pause the video and take a look at the problems of the day. So 8.6 is called Solve Rational Equations. It says here we will use cross multiplication to solve a rational expression when each side is a single rational expression. That is what we are looking at today for part 1. So what that means here, if you take a look, we have one fraction equal to another fraction. One fraction equal to another fraction. What happens is I cross multiply. I'm going to type that out here, which means I get 7 times 2x minus 10 equal to the other diagonal, which is 11 x minus 2. So 7 times the quantity 2x minus 10 equal to 11 times the quantity x minus 2. So we use cross multiplication to get rid of the fractions. The reason why I kept parentheses around the 2x minus 10 and the x minus 2 is next we have to distribute 7 to both. In this case, the 11 to both. So let's see what happens here. So now I get 14x minus 10, or minus 70. Let's keep space here this time. Equal to 11x minus 22. In this step now, it's a multi-step equation. I'm going to bring the x's to the left. 14x minus 11x. 11x becomes negative when we move it over. Equal negative 22 plus 70. Negative 70 comes over as a positive. We get 3x equal to 48. When I divide both sides by 3, your final answer is 16. And that's it. That's my answer. So pause the video and try the second one. Once again, it doesn't matter which diagonal I start with. I'll start with this one. Negative 4 times the quantity x minus 3 equals their diagonal 5 times the quantity x plus 3. So I'm multiplying my diagonals out here. From here, I'm going to distribute the negative 4 to both. I get negative 4x plus 12. Watch your signs change. Equal to 5x plus 15. Once again, remember we are distributing. Don't forget to put parentheses around x minus 3x plus 3 because we're distributing to each of them. All right. From here, bring the x's to the left. Negative 4x minus 5x equals 15 minus 12. Negative 4x minus 5x is negative 9x equals 3. And now be careful when you divide. I'm actually going to divide negative 9 by both sides. My fraction is going to simplify. X is going to equal negative 1/3, not negative 3. We know that because the number in the denominator is bigger, so it's a fraction. So my x will equal negative 1/3. All right. So here's our example today. In this case, we're going to solve by using cross multiplication, because if you look, there's one fraction on the left, one on the right. But we also have to check for extraneous solutions, and how you know that will happen. Chances are you're going to have to factor. You get two solutions. We talked about extraneous solutions before. I'll give you a little bit more of a heads up on them as we go. All right, so I multiply the first diagonal and get 1 times the quantity 11x plus 8 equals the other diagonal x times the quantity 2x plus 5. So that's my cross multiplication here. Next, let's distribute the 1 to both, and x to both. Get 11x plus 8 equals 2x squared plus 5x. Now, do you see I have an x squared? I like my x squared to be positive chances I'm going to have to factor in the next step. So move everything on the left over to the right. So I'm going to keep it as 0 equals 2x squared plus 5x. I'm going to bring up the 11x over is negative 11x. Positive 8 over is negative 8. Now we'll combine like terms. So 5x minus 11x is negative 6x minus 8. Now if you notice, before I break them up into two parentheses, do you see how they're all divisible by 2? Factor out the GCF of 2 first, the greatest common factor. Now we could do our two parentheses sets, right? Think of how you factor this. It should be x minus 4, x plus 1. Now remember, when you divide, I'm going to show you this step here. We can actually divide both sides by 2, right? To get rid of the 2. What happens here is they cancel out. And 0 divided by 2 is what? 0. So you're left with x minus 4, x plus 1. And we'll set them each equal to 0. X will equal 4, negative 1. Once again, there goes that bell, huh? All right, I'm sure you guys are used to it by now. Now, when you have two solutions, you need to check for extraneous solutions. If you remember, we've done it a few times this year. You have to check both into the original, one at a time. Sometimes one solution works, sometimes both, sometimes none. You don't know until you plug them in. All right, so I'm going to start by plugging in the 4. One at a time. I'm going to write a little bit differently here, so just so you guys are okay with this. Move this over here. So plug my numbers in. This is a fraction. Equal. This is a fraction here. So from here I get 1 over 2 times 4 is 8. 8 plus 5 is 13. All right, that's my first one. See if it equals. Let's type our other fraction out. We get 4 over 44 plus 8 is 52. There's a common number we could factor out of 4 and 52, right? Both have a 4 in common. 4 divided by 4 is 1. 52 divided by 4 is 13. So actually, this is a true statement, right? 1/13 equals 1/13. All right, so 4 is okay. You don't have to cross it out. Let's try the next one, or the last one, I should say. Plug in your negative 1. I'll add my fraction bar as an equal sign in a minute. Here's what we get, equal to this. All right, so I get negative 1 over negative 2 plus 5 is 3. Oh, actually, I'm sorry about that. This was just a 1. I copied it wrong. Move that up. So get 1/3 equal. It's negative 1 over. I get negative 11 plus 8. Negative 11 plus 8, I'm just going to change it right to negative 3. And what is a negative divided by negative? I'll write it down here. Well, this is 1/3. Negative divided by negative is a positive. So you get 1/3 equals 1/3. And that's correct. So in this case, both check out. So once again, you have to check one. You have to check both of them. Sometimes one works, sometimes both, sometimes none. All right, that's it for today's lesson. Problem of the day, and then complete the following problems, or actually problem. Assignment 12, I want you to do number 2. That's where we're going to stop.